now we are in part 2 of our intro to R, intro to graphical data analysis. So this is kind of the portion explaining what R is, why we use it, general vocabulary, and things like that. Yep. So R is versatile, free data analysis software that is really widely used by scientists. Does a lot of different things, but more specifically, it organizes data, it analyzes data, and it graphs data. So basically, it has everything you need as a scientist. There's R, then there's RStudio. RStudio is a program that makes running R a lot easier and more organized. That's what we're going to be using. It organizes your code, data, and graphs into one program, and it's just a lot more user-friendly, a lot easier to use, and this is why we use it. And then explaining why we use R versus Excel or Google Sheets. I know that you guys use those for 103. The biggest difference is that when you go into Excel or when you go into Google Sheets, it has everything in the program that it can do for you and you can access it. So you say, Excel, you go to the graphs bar and it lists kind of all of the graphs that it can do for you. R is kind of the opposite, where it is a blank slate and you tell it exactly what you want it to do for you. So it's almost backwards. And that's what makes it a little different, is because when you tell the computer, you tell R exactly what you want it to do, you can't just talk to it and tell it. You need to use the specific coding language, which is kind of sometimes a little frustrating to take on at the beginning. But once you understand the language, and not only understand the language, but you find your resources where you can directly copy and paste that coding language into R, it's a lot easier, and there's just so much more you can do with it. And what is also kind of cool and interesting with R is, since it's free and it's kind of open access, any scientist around the world has access to download this software. So once you have your code or your language of you telling R exactly what you want it to do, you can very easily replicate it and send it to other scientists, or get, that code from other scientists and use it for yourself. So it's very engaging within the entire scientific community. So some general vocabulary that you will probably hear us talking about in class or online, and just various things that you should know that, R may say, or you'll see pop up and you should know what it means. One of them is the R script. That's the line of code that you are writing. You're going to open up an R script when you enter R as a program and save your files. In the next YouTube video, I'll teach you how to do that. A variable is the way to store your data for use in the R script. So kind of basically little packages of data that you're analyzing are the variable. The R project as a whole is your R script, all your data, so your variables, and then your current R environment, which we'll go talk about later. A package is a set of functions or codes that you can load into your script. A couple examples of those that we use a lot in this class are gsheet or ggplot2. How I kind of think of packages when I first started coding is that you may have a game, I can't think of any off the top of my head, but you buy or you collect expansion packs to kind of expand what the games can do, or maybe the different characters, the different things you can buy, whatever. Packages it's kind of a set of a function that you type it into R, and then you're letting know what R needs to pull from kind of the back sellers, if you will. Because if R had every single tool or capability that it has already kind of loaded into your program, it would be incredibly slow. So if it's a day that you're going to be just pulling data from a Google Sheet versus pulling data from Excel, you're going to load the package gsheet. So you tell R, okay, I need you to get the capacity to be able to download this file from Google Sheets, etc. Whereas ggplot2, you type in ggplot2 into your R and you use that package because you need to tell R, okay, we're going to be graphing today. We're going to be doing box plots. So it kind of tells R exactly what you want it to do. A function is an action or calculation that you perform on your variables. So this can be finding a subset, getting a mean, creating a plot, loading a package. And you load a package by saying library. And then finally, comments are how you describe code. When you type into R and kind of you're speaking to R in its language, it's going to try to read everything as if you're talking to it, basically. In order for it to understand, you need to be typing in a specific coding language. But if you don't want to type in that coding language and you just kind of want to write a note to yourself to explain what you're doing, you kind of type in a hashtag or the number symbol. Then once you type in the hashtag, your text will turn green. And by then you can say, okay, this package I'm about to load on the line below is how you upload data from a Google Sheet. And when you include that hashtag, basically R skips over that line and doesn't try and understand it or read it as code. So by the end of this semester, you'll be able to import data and create box plots. You're going to learn that from assignment 1. You'll create scatter plots, which you'll use on assignment 2. Assignment 3 uses standard error bars and t-tests. And then assignment 4, you combine all of these skills. And then goals for lab 1 are to make a properly formatted summary table. Make sure that you go on the previous presentation to understand how to format a summary table. You're going to import data from Google Sheets into R. You're going to save that data as a variable. You're going to create a box plot of your diversity data, and then you're going to plot subsets of your data.